Hello there, and welcome to Cafe con Chemistry. Today, we'll be discussing one of my favorite topics, kinetics. Hopefully, you'll enjoy it as much as I do. We will be discussing what is chemical kinetics and factors that affect a reaction, including concentration of reactants, physical states of reactants, and temperature. Let's first begin with defining chemical kinetics, which studies how fast the reaction occurs by monitoring the change in concentrations of reactants or products over a period of time. This monitoring of concentrations is known as the reaction rate. As we begin to go more into kinetics, we begin to observe that different reactions will have different rates. In some cases, we might have a fast reaction, which simply means that the reaction concentration decreases rapidly, and this results in a higher rate. The opposite is true for a slow reaction, which will have a slower rate, where a rate is the measure of change in concentration of a reactant over a period of time. Not all reactions have the same rates, and this can be attributed to the nature of the reactants. In addition, these rates can also change depending on the conditions. 4 factors in particular that we can control as scientists are the starting concentration of reactants, the physical states, the temperature of the reaction, and catalysts. We will focus and go into depth for the first 3 factors, and we will come back to a catalyst in a later discussion. Let's think about a reaction and why might concentration affect the rate. Let's take, for example, the following reaction, which occurs in the gas phase. Nitrogen monoxide reacts with ozone to produce nitrogen dioxide and oxygen. In order for this reaction to occur, the reactants nitrogen monoxide and ozone must first collide with each other in order to react. So, how does concentration play a role? Well, by increasing concentration, we increase the number of collisions, which in turn can affect the reaction rate. This leads us to the following conclusion. The rate is proportional to the collision frequency, which is proportional to the concentration. You'll begin to notice a trend about how important collision frequency is in respect to rates of reaction. The physical state of the reactants play a significant role in reaction because molecules must mix in order to collide. So the physical state determines if your reactants can mix with one another and react. For example, if the reactants are both aqueous, then the random thermal motion will allow them to collide with each other. However, if the reactants are in different phases, then collision only occurs at the point of contact between the phases. This brings into consideration surface area. The more surface area that is available allows for more contact to be made. One way to increase surface area of a solid is to grind it into smaller pieces, because this allows for more contact surfaces to be present. The last factor we will focus on is temperature, which is actually a measure of the kinetic energy of the particles that make up a surface. Molecules require energy in order for them to collide. There's that word again, collision, which is why temperature plays a major role in the rate of reaction. Let's look at why. Let's take, for example, an avocado. What happens when you have an avocado in your refrigerator versus 2 on your counter? Well, the avocado on your counter will ripen faster than the one in your fridge. This is a result of the temperature, because at lower temperature, the process that ripens your fruit is slowed. The same thought process can be applied to a reaction at lower temperatures. The speed of reaction slows down and has less collisions, resulting in a lower rate. Whereas higher temperatures, you're increasing the frequency of collisions so more molecules react. The following statement can be made. Rate is proportional to the collision frequency, which is also proportional to the temperature. Another important component to also consider for temperature is energy of collision, which simply refers to the energy required for molecules to react, because in some cases, molecules might hit each other and simply bounce off each other without actually reacting. This is a result of not having sufficient collision energy. At increased temperature, the collision energy also increases, which allows more molecules to react. I know we covered a number of definitions and concepts, but as a brief recap for this lesson, we covered 3 factors that affected the rate of a reaction, which are concentration of reactants, 2, physical states of reactants, and 3, temperature. It is important to be able to describe why each of these affect the rate. Thank you and have a wonderful day.